Now, we can always use Desmos or a graphing calculator to find inverses of our matrices, but there is kind of a quick formula just for 2 by 2 matrices. So it's right here. If you have this matrix A, that's A, B, C, D, then the inverse, let me get a pencil so you can see this. So for the inverse, you take 1 over AD minus BC. So notice those are multiplied on kind of cross multiples of each other. And then, I'm trying to get an eraser here. And then we have D and A. These two switch places. Okay, so notice they switch places over here. And then B and C, they just switch signs, so they both become negative. And again, that's a way to find the determinant just for a 2 by 2 matrix. Now, this thing down here in the denominator, that AD minus BC, it's something called the determinant, and we're going to use that in the next video. So we want to find the inverse of matrix A. Yes, we can go to Desmos and do it there, but I want to use this little formula. So the inverse is going to be 1 over, we have AD minus BC. So this times this, which is 20, minus this times this, which is negative 3. And then we have our matrix. So to deal with this matrix, we flip the numbers on the main diagonal. So the 4 and 5 switch places. And then the other two, they just change signs. So positive 1, negative 3. So our inverse is going to be 1 over 23 times this matrix, 4, 1, negative 3, 5. And we're just going to multiply everything in that matrix by 1/23. And so we get 4/23, 1/23, negative 3/23, and 5/23. Okay, so that's just a little shortcut for finding inverse matrices only for 2 by 2 matrices. So here is one of the ways that we can use inverse matrices in actually a helpful way. So what I'm going to do is I'm going to rewrite this whole thing as a matrix equation. Okay, so remember we did these coefficient matrix. So these are the coefficients, 1 and negative 2, and then negative 3 and 2. And then I'm going to write a variable matrix, x, y. And when we multiply those, we should get our answer matrix, which I'm going to scoot over just a little bit. So our answer matrix is 1, negative 11. Okay, so I've just turned that system of equations into a matrix equation. And what I would like to do is I would like to solve this for xy. I would like to get this xy matrix by itself, which means I need to get rid of this thing. Now, there's no such thing as matrix division, so it's not like I can just say like, oh yeah, I'm just going to divide both sides by that matrix. That's not a thing. What we're going to do instead is we're going to find the inverse of this matrix. I'm going to find the inverse of matrix A, and I'm going to multiply it over here. So that, because remember, inverses undo each other. And if I multiply it here, I have to multiply it over here too, okay? Now, what's left is, let me make a little more room for that. We need to find out what that inverse matrix actually is. Okay, so that's going to be our first task. So our matrix A is this one here in blue, 1, negative 2, negative 3, 2. And so I want to find the inverse of A. Now, I can use that little formula that I used before. Instead, I'm going to go use the Desmos calculator because it's pretty easy to use. So we'll do a new matrix. This matrix is 1, negative 2, negative 3, 2. Just hit enter, and then the Desmos call this matrix C, which is fine. We're going to do the inverse of C. And notice it has decimals. If you want them as fractions, you just press that fraction button. That takes it back and forth from fractions to decimals. So this is our inverse matrix. So let's come back over to the notes. So that inverse matrix was negative 1/2, negative 1/2. I should have written bigger. Negative 3/4, and negative 1/4. And I'll write that better up here. So what I'm going to do is I'm going to multiply up here by that matrix. So negative 1/2, 1/2, negative 3/4, and negative 1/4. If I multiply by that matrix here, I have to multiply by that matrix over here, which I'm going to need more space. Just get that over. So negative 1/2, negative 1/2, negative 3/4, and negative 1/4. Okay, and also remember over there was still this answer matrix. Okay, so now what happens is when we multiply these two things, these are inverses. So they are going to give us the identity matrix. Okay, guaranteed. You can do it yourself if you want, but it's going to give us the identity matrix. And then when we multiply the identity matrix by xy, well, that's just like multiplying it by 1. So we're just going to get xy on this side. So these matrices just basically canceled each other out. So now all we need to do is multiply these two equations on the right. Now, this is a 2 by 2 matrix and a 2 by 1 matrix. So we can multiply them, and our answer is going to be a 2 by 1 matrix. So we're going to take row 1 and column 1, which is going to give us negative 1/2 plus 11/2. So that's 10/2, otherwise known as 5. You can use your calculator for this too. And then we're going to do row 2 by column 2. So that's going to give us negative 3/4 plus 11/4. So that's 8/4, otherwise known as 2. So we have solved this matrix equation. X is 5 and y is 2. So we can use inverse matrices to solve systems of equations. It's just another way to do that. In 10.1, we learned how to use reduced or echelon form to solve this. So is one easier than the other? Maybe, maybe not. It just depends. But I just wanted you to see another way to solve those systems of equations.